Very good morning, dear students. So today's session, I'm going to start the new subject, digital image processing. What for these digital image processing? What purpose we are going to study this subject and which areas they are going to use for real-time applications. And all these things we are going to discuss one by one. So in this subject, uh, we have mainly important few modules. As per the university, we have these 5 modules. So one by one, I will going to discuss. The first module, now we look into the digital image fundamentals. So here, some fundamental components of digital image processing. What are the different steps are available for digital image processing, and including from how to capture an image and how to represent an image. These two things is very important. In any digital image processing, first, how to capture an image, what background, what is the quality of camera, everything now we are going to discuss. Then after once you have to capture an image, how to represent an image. So here the representation and processing, it will depends on only digital image. Some different kinds of images are also available. For example, binary image, it is called as a white and black image. Second one, it is a grayscale image. The grayscale image, the pixel values start from 0 to 255. And then the last one is indexed image. Indexed image is nothing but color image. We have the combination of RGB. Each component have 0 to 255. And then second module. In the second module, we look into the image enhancement. What for image enhancement? The image enhancement is nothing but improve the quality of an image, or it looks better. In this image enhancement, we have mainly two main domains. One, it is called as spatial domain. Second one, it is called as frequency domain. What for these spatial domain? In this spatial domain, in the first level, we look into the relationship between the pixels. It means that neighboring pixels, that we have to represent it in the form of N4. N4 is nothing but neighboring 4 pixels to be considered, horizontal and vertical. And similarly, ND pixels. ND is nothing but only the diagonal pixels to consider. And the combination of N4 and ND, it will become N8. Both horizontal, vertical as well as diagonal elements. And along with that, before going to process any image, we understand what is the value of the pixels, how much we are going to improve it. To understand the value of an image by using histogram processing. Here, histogram processing, histogram equations, all these things we are going to discuss in this module 2. And similarly, the remaining module 3, here same enhancement technique with other domain, frequency domain, by using different kinds of filters to enhance the image. And fourth module, we look into the image restoration. Restore the degraded images. So some different restoration techniques are available. So we're going to discuss one by one in that particular module. And the last module, it is nothing but morphological image processing and color fundamentals. Some of the color images, conversion of RGB model into different kinds of modules and morphological operations. All these things we are going to discuss from this module 5. So, the purpose of the subject, because nowadays the outcome based education system. The outcome based education system is nothing but everything it will become output based, outcome based. The course outcome we are going to discuss. In each module, we have some COs, course outcome is defined. This course outcome is defined by the university also. As per the course outcome, we cover the syllabus, we conclude it. So first one, it is describe the fundamentals of digital image processing. In the first module, what we covered, we fulfill with this course outcome. And the second one, it is understand image formation and the role human visual system plays on a perception of gray and color image data. So here, in the first module itself, some of the concept what we are going to explain human perceptions. That is very important. In any object, I think to be considered what way you are going to human perception. That is way it is very important. And similarly, third course outcome, apply image processing techniques in both spatial and frequency domain. In module 2 and module 3, I explained about that enhancement technique. In the enhancement, we have spatial and frequency. The frequency is nothing but Fourier. And fourth module, we look into that. I explained that evaluations, representation of an image. So here, design and evaluate image analysis techniques. We have to fulfill this course outcome. These are the course outcome fulfilled once complete the subject. And these are the textbook. One best textbook for these image processing is a Gonzalez Digital Image Processing, 3rd edition. It is available in the library. We can refer it. And then the reference books, Digital Image Processing, SJBIT. And another one is very famous book, Fundamentals of Digital Image Processing by Anil K. Jain. These are the textbooks it support for as per the syllabus. So now we'll come to the fundamental components or fundamentals of image processing. So here, one picture is worth more than 10,000 words. Now we'll come to the definition of what is digital image, what is digital image processing. This definition is very important. Now, before going to define the digital image processing or digital image, the representation of image, it is a 2D image. For the analysis, what we considered, it is 2D image. This digital image processing is the user or is the use of computer algorithm to perform image processing on digital image. That is what the definition of digital image processing. How to process it? We can process the digital image by using some of the algorithms. So in the definition, what we mentioned is a computer algorithm. That is nothing but software algorithm used to perform the processing techniques. That is what we definition of digital image processing. Now next, what is digital image? The digital image is a numeric representation. Normally, it's a binary of 2-dimensional image, f of x comma y. X and y are the coordinates and f is amplitude of an image. composed of a finite number of elements, each of which has a particular locations and values. Because we want to find out that pixel value, first you have to find out the coordinate values. That is what I told, that it is called as f of x comma y. X and y as a coordinates. F is nothing but amplitude. These element is called as a pixel or a picture element. Now, in an image processing, the important basic concept, pixel or picture elements. So now we'll come to the some representations of a digital image with a continuation from the previous slide. Definition of digital image. A digital image is a representation of two-dimensional image as a finite set of digital values called picture elements or pixels. Now in these representations, so in these representations, now we look into that x-axis and y-axis. X-axis represent vertically, y-axis represented horizontal lines. Any image to be considered, that is called as f of x comma y, where x and y are spatial coordinates and the amplitude of f at any pair of coordinates nothing but x comma y. The f is nothing but the intensity or gray level images. So here one important thing to be observed, you have to consider f of 0, 0. That is what origin. X is 0, y is 0. If keep on increasing x value 1, 2, 3, 4, 5 like that, may be considered as a maximum m minus 1. And similarly, in the y-axis, you can increase from 0 to n minus 1. That is what the pixel. Suppose I want to find out f of 2 comma 3. 2 is nothing but x-axis. 3 consider as y-axis, f of 2 comma 3. So now we'll come to that, how to represent digital image. We have the digital image, how we are going to represent it. See, all of you look into this slide, very clearly mentioned. So it is digital image, f of x comma y is a digital image. The coordinates to be considered, image elements are pixels, that particular pixel. Now we have to start from f of 0, 0 to f of 0 comma m minus n. Similarly, in the x-axis, we have to start from f of 0, 0 to f of n minus 1 comma 0. It means that the image are represent in the form of numerical representation with respect to the matrix. The image size may be represented as 2 cross 2 or 3 cross 3 or 4 cross 4 or 16 cross 16, etc. So these individual pixels have to be considered to represent. So now, once we clear about to the definition of digital image, now we look into the different types of images. Mainly, we have three types of images. One, it is called as a white and black images. A few years or a few decades back, even pictures or any kind of images is only white and black. Second one, it is a grayscale images. The grayscale images till today it is very popular because in the medical field they are going to use only grayscale images only. The last one, it is a indexed image or colored image. These are the three different types of images are available. So now we'll come to the one by one in detail explanation of each type of image. White and black images. They are also white and black images. They are also called as a binary image. Binary is nothing but 0 and 1. So here it is very simple representation. 1 is called white, 0 is called black. Means that 1 is represent as a white color, 0 is represent as a black color. Only two colors. That is what binary image is. 1 and 0 only. So similarly, another type of image, gray image. The gray image alternate name is called as intensity images. Here the intensity values the range from 0 to 255. 0 is nothing but as per the previous type of image, binary image, 0 only. 255 is nothing but 1. In between 0 and 1, we have levels, 255 levels, 0 to totally 256, but you have to start from 0 to 255 range. And the last one, it is color image. This may be represented RGB image or index image. Each component RGB, each component have 0 to 255, green also 0 to 255, and blue also 0 to 255. This range of combination of images available in these indexed images. Okay, this is what I want to explain it. Once I'll conclude it. Definition of digital image, processing of digital image, representation of digital image, then types of digital image. These three topics is very important. If you go to the next level or next classes, I'm going to explain in details operations and some block representations or fundamental components available in the digital image processing. I'm going to explain. So, shall I end up today's sessions? I will continue in the next session, the next class. Thank you. Thank you very much.